Hello there, my name is Calvin Rands and I am the track coordinator for the Aerospace Structures and Materials Master Track at the Faculty of Aerospace Engineering. If you have clicked on this video, that means you are likely thinking about the possibility of enrolling in this track next year. So let's take a look at what this track is all about. The Aerospace Structures and Materials track, or ASM track for short, is focused on what is needed to design and build the aircraft and spacecraft structures of tomorrow. What does this entail exactly? Well, in order to realize these structures, we need to start with understanding the materials they are made from. We then have to look at how we can combine and shape these materials into parts, assemblies, and the final desired structure. Of course, this can only be done after a thorough evaluation of the safety and durability of the structure, which is linked to the detailed analysis of the demands placed on the structure. Finally, all of these topics are linked by a design and optimization process aimed at making the most weight-efficient structure. Now that you know what ASM is all about, what challenges exist in the field which are driving research within our department? Well, let's start by representing the present-day aerospace structures by this simple structural icon. Not too complex, and indeed we're quite capable of designing and building such structures. But if you look at the direction which structures are heading, you start to see more and more complexities arise. Novel materials such as self-healing composites, the need to be more sustainable, including complexity inspired by what we see in nature, and adding multifunctionality, doing more than just carrying loads like old structures did. And finally, smart structures with embedded sensors and diagnosing equipment. If we relate these to our previous themes, it raises many questions such as how to deal with these complexities in design or how to ensure that they are safe. And these are just some of the questions that arise and that we explore with our education and research within the ASM track. If you decide to join our track, you will have your choice of 3 different profiles to specialize in. The Materials and Manufacturing profile is for students who are interested in developing new, high-performing materials and advanced manufacturing technologies for aerospace applications, ranging from designing materials at a microscopic level to applying novel manufacturing methods for the creation of complex structures with enhanced durability and functionality. We like to say that these students like to turn atoms into aircraft and spacecraft. The Design and Safety of Structures profile is for students who are interested in creating innovative, robust, and durable lightweight structures that combine accurate experimental, analytical, and computational methods to predict and optimize the performance of these future aerospace structures. Students in this profile become experts in understanding and learning from failure so the public can feel safe and secure. Finally, we have the Structures for Space profile, which is for students who want to join the rapidly growing space sector as structural engineers in design, analysis, and verification of the next generation of spacecraft, satellite, and launcher structures. Students in this profile will get a taste of the perspective of the previous 2 profiles, but from the unique context of the demands for spaceflight. Unique to the ASM department is the completely flat structure with no distinct research groups tied to individual profiles. What does this mean to you? Well, it means that regardless of the profile you are studying within, you are free to complete your thesis with anyone in the department and even on topics outside of your profile. This gives you a lot of flexibility to pursue research and thesis topics that interest you without being constrained by the profile choice you are making early in your studies. Speaking of research, we are lucky to have an amazing structures and materials laboratory and the ASM Field lab. But rather than me telling you about it, I'll let some of my colleagues show you.
Let's meet some people and the labs they work in.
Hi there, I'm Sherry Wang. I'm an assistant professor here. I optimize future aircraft design by doing interdisciplinary research on aerodynamics, structural dynamics, flight dynamics, and control theory. Today I'm working on the Smart X wing, which is an active moving wing that can adapt its shapes to different flight conditions and missions, just like birds do. With multiple axis accelerometers, we can monitor the dynamic responses of the wing, and with the 3-dimensional laser vibrometers, we can identify the structure mode shapes. By actively adapting the wing shape, we can reduce the energy consumption by up to 30% and contributing greatly to sustainable aviation.
The Dynamics Lab is part of a highly advanced lab, the Aerospace Structures and Materials Lab. This huge aircraft hall is full of equipment and labs, from a chemical physical lab to laser facilities, a composites lab, and equipment where we can destructively test the materials and components we make. This is the best way to learn how to improve safety. A key component in aircraft safety is to have reliable methods to assemble individual aircraft components. Hi Bram, can you show us around your lab?
Welcome in the Composite Welding Laboratory. In this lab, we perform research on welding technologies for thermoplastic composites. Welding is a very clean technology that makes use of heat and pressure to fuse two parts together. And in this lab, we developed our continuous ultrasonic welding technology, which is very new, very efficient, and very, very fast. To further develop and mature it, we take it to our field lab SAM XL, where we further scale it up and de-risk it so that it can be used on a large scale to actually weld real aircraft structures.
Welding can make aerospace structures smarter, lighter and cleaner. 3D printing can do so as well. Let's find out how and meet Kanal.
Hi, I'm Kanal Masanya. I'm Associate Professor in the faculty and welcome to the 3D Printing Lab. Here we try to replicate the intricate designs of materials that you find in nature using 3D printing technologies. And we exploit nanoscale self-assembly together with shaping freedom of additive manufacturing to realize next-generation sustainable aviation materials. Here we focus mostly on fundamental science, and what's really exciting is that we can collaborate with the field lab SAM XL to quickly bring our ideas into implementation that can impact society in the future.
That's fascinating! In this Aerospace Structures and Materials Lab and in Field Lab SAM XL, our researchers and students work on creating better, lighter, safer, smarter and, above all, more sustainable materials and structures.
So what happens when you finish your master's degree within our department? Many of our students go on to be engineers directly within the aerospace industry, designing the next generation of aircraft and spacecraft. But that is not the only sector that desires the type of skills and knowledge you will gain in ASM. Lightweight structures and materials are becoming increasingly relevant across a wider range of engineering disciplines, with the increased focus on sustainability. Furthermore, the critical thinking and problem-solving skills you will learn are highly desirable in consultancy, startup, and even management environments. The biggest challenge for you in your career might just be narrowing down what option you want to pursue. Thank you for taking the time to learn a little bit more about the ASM Master Track. I wish you much success in your future master degree endeavors, no matter which track you choose. But I hope ASM continues to be one you consider.